you guys remember, we have studied that. So thermometric substance is a substance whose property is under observation in order to get the idea of change of temperature. So when it comes to a liquid, we discuss liquid in glass thermometer, whose rise in liquid or thermal expansion is under observation, which tells us जिसकी प्रॉपर्टीज हमने ओ लेवल्स में पढ़ी भी थी, which is now out of the syllabus now, that if the thermal expansion is linear thermal expansion of a substance, thermoplastic substance की कौन कौन सी प्रॉपर्टी होती है? Visible to naked eye, doesn't stick with the apparatus, and have uniform thermal expansion. So we can get the idea of change in temperature by how many properties? We can get the idea by change in color of a substance. Will let us know that the temperature has changed. Expansion of gas, या expansion of anything, ठीक है? Or change in resistance. And change in resistance की एग्जांपल हमने कहाँ पे पढ़ा था? Thermistors के केस में. The thermistors are negative temperature coefficients whose resistance change as the temperature changes. Negative temperature coefficients NTC हमने पढ़े भी हैं. NTC. So change in color, if the color is changing, that means temperature is changing. We cannot predict the value of temperature, the magnitude of temperature, but we can tell that a temperature has changed by looking into these properties. So if we go with this factor, the first thing, including the density of liquid, we know that we use mercury or liquid in red alcohol for liquid in glass thermometer, mercury and red alcohol, because what is the reason? Because they fulfill all these properties. And why do not we use liquid water for that? Because its density is much less as compared to mercury and red alcohol. So वॉल्यूम ऑफ अ गैस के अंदर एयर की एक्सपेंशन, जो अर्ली थर्मोमीटर्स थे वो वॉल्यूम ऑफ एयर की एक्सपेंशन ऑफ एयर के अकॉर्डिंगली टेम्परेचर मेजरमेंट्स करते थे. वी हैव स्टडीड इन टेम्परेचर इन ओ लेवल्स दैट विद द इंक्रीज इन टेम्परेचर व्हाट हैपेंस? What happens with the increase in temperature?
For what?
Gas expands. So if the expansion is occurring, that means temperature is increasing. If the gas is contracting, that means temperature is decreasing. That could also be associated with the third thing that they have discussed about the pressure. So if the pressure is increasing, that means temperature is increasing. If the pressure is decreasing, that means the temperature is decreasing as well. So by looking into the pressure of the gas, we can also predict that a temperature is increasing or decreasing. Obviously, we need to calibrate the thermometers accordingly if we are going to use these properties. And we know that at a certain temperature, the values are noted, and then a whole calibration is done upon the known values, and then a thermometer is designed. Thermocouple we have studied in O levels as well. Thermocouple gives us the temperature change in terms of EMF, and it's calibrated in such a way that the EMF would be calibrated to give us the temperature of the system. Thermocouple is the most efficient thermometer, and it is mostly used in areas where high temperatures are needed to be measured or very sensitive temperature measurements are required. At that point, thermocouples are used. They are robust. They give the temperature changes immediately. They're very sensitive to temperature changes. These are the following reasons. We choose them for the areas where the temperature sensitivity is very much needed. Clear? Then we have the thermodynamic scales. What is the thermodynamic scale? Celsius, Fahrenheit, and Kelvin. And yeah, but the second point, understand that the scale of thermodynamic temperature does not depend on the property of any particular substance. It has a fixed value, or that is outside the context of our syllabus. But thermodynamic scale की जब हम लोग बात करते हैं, so वो है होता है हमारे पास. We define thermodynamic scale as, let me give you the definition of thermodynamic scale as well. ट्रिपल पॉइंट ऑफ वाटर के बारे में आइडिया है? ट्रिपल पॉइंट ऑफ वाटर. हेलो, कैन यू हियर मी?
जी सर। आइडिया
हाँ नहीं सुना हुआ।
व्हाट इज ट्रिपल पॉइंट ऑफ वाटर?
सुना नहीं हुआ कभी।
ये हमारा पास ऑथेंटिक थर्मोडायनामिक स्केल है व्हिच गिव्स अस दैट at 273.6 Kelvin water exists in all its three states: ice, water in liquid, sorry, and gas state. So 273.6 is considered as the thermodynamic scale of temperature, and this tells us that it is temperature independent. उसका जो फॉर्मूला होता है, it's given as T equals to 273.6 Q over Q3, where Q is the heat absorbed or lost by the system, and Q3 is the heat absorbed or lost at triple point of water. And T is the unknown temperature. Let me choose any other color. It's not readable here. Let me try this. It is the unknown temperature. So this point, that it is independent of this point, independent of particular substance, this is justified by this equation. Okay?
ओके।
Then I convert the temperature between Kelvin and degree C. The formula is given right in front of you. We are familiar with this, how to do that. Understand that the lowest possible temperature is 0 Kelvin on thermodynamic scale. And this is given as 0 Kelvin is equals to minus 273 degrees C. And this is known as absolute zero. How do we define absolute zero? Generally, it is the point at which the kinetic motion of the particle becomes almost zero. ठीक है?
ठीक है.
Then we have specific heat capacity and specific latent heat capacity. So we know that the specific heat capacity is defined as the, how do we define specific heat capacity? The amount of heat energy required to raise the temperature of a body through 1 Kelvin or degree C. The amount of heat required to raise the temperature of the body through 1 Kelvin or degree C. Upon the examiner, दोनों mention out कर देना. And the formula is given as, specific capacity is given as small c into is equals to Q over m delta t, और delta theta भी mention out किया जा सकता. Here Q over m is given as heat capacity. Okay, we have missed one part and no one corrected me for it. इसमें एक और important चीज mention out करनी होती है. And what is that?
Oh, same temperature?
No,
Constant temperature?
no. Ali?
1 kilogram.
Yes, of the body of 1 kilogram through 1 Kelvin is specific heat capacity. Then we have used specific latent heat. Latent heat के अंदर वो आता है at fixed temperature. Latent heat of fusion and vaporization is both given as Q is equals to ml. If it's vaporization fusion, it would be LF. If it's vaporization, it would be LV. इसको कैसे डिफाइन करते हैं अली? How
Latent
do we
heat.
define latent heats?
Latent heat, amount of heat in it. Latent heat of vaporization. Amount of heat energy required to change the state of 1 kilogram of substance from solid to liquid at constant temperature.
Solid to liquid fusion होगा at its melting point and liquid to gas vaporization
वो
होगा at
vaporization,
its
जी जी.
boiling point. ये
Boiling
terms
point.
mention out करना जरूरी होती हैं, otherwise our marks will be deducted.
Sir, for specific heat capacity, it can be 1 Kelvin or 1 Celsius?
हाँ, we can go for the both.
Okay.
Then I use specific distinguish between specific latent heat of fusion and vaporization. We have discussed that in terms of definition. The next part is 15, which tells us the ideal gases. Ideal gases क्या होती हैं? How do we define ideal gas?
Which obeys PV equal to nRT for all
Yes,
values of
which obeys
pressure.
the gas laws. Boyle's law and Charles' law in general. What is Boyle's law?
Pressure inversely to volume.
Yes. Boyle's law में क्या बताता है? That if temperature is kept constant, pressure and volume is constant. उनके two graphs हमने पढ़े हुए हैं. एक ये आता है when we draw pressure versus volume, and one is this when we discuss about pressure and inverse of volume. The next, the second law is Charles' law, and that is V over T equals to constant. This tells us that temperature is proportional to kinetic energy. ये हमने वैसे भी पढ़ा हुआ है. Pressure is proportional to kinetic energy, so pressure is proportional to temperature as well. जो हमने gas laws के अंदर find out भी किया था. Product of PV equals to is proportional to T, obeys Ohm's law. And ideal gas. Then we have recall the use of the equation of an angular PV equals to nRT when n is equals to this factor. ये हम लोगों ने study कर लिया था in our detailed lesson. The only thing that we need to put here is few of the constants, which is what is the equation for pressure that we have studied? Pressure is equals to 2 by 3 n over v into kinetic energy. So if we discuss about जो है Boyle's law, so Boyle's law में टेम्परेचर क्या रहता है? Constant. So if temperature is constant, so is kinetic energy. So this factor, and this all is constant. So in place of that, we'll put constant over volume. So hence proven the Boyle's law. If we go for the Charles law, for that we need to go for again this equation. But before that, we go for PV is equals to nRT. Here R is the general gas constant and has a value of 8.3 joules per mole into Kelvin. And moles क्या होता है? How do we define mole? Mass
Amount of
over
substance.
molar mass. And 1 mole of every substance contains equal number of atoms, molecules, ions, and everything, and is equals to Avogadro's number. Avogadro's number क्या होता है? 6.02 × 10⁻23. And here n is given as number of atoms over Avogadro's number. Na basically Avogadro's number को show करता है into R into T. So from here, R over Na gives us the Boltzmann constant, which is K. R over Na is equals to K, the Boltzmann constant, and its value is equals to 1.38 into 10⁻⁻23 joules per Kelvin. So the equation becomes N PV is equals to capital N, K and T. इसको फिर हम किससे मैच करते हैं? With the other equation, this one. If we rearrange this equation, let's rewrite that equation here. P is equals to 2 by 3 N over V into kinetic energy. So यहाँ से PV किसके इक्वल आ जाएगा? 2 by 3 N into kinetic energy. अगर हम इन दोनों इक्वेशंस को आपस में रिलेट करें, so that would be NKT equals to 2 by 3 N into kinetic energy. Cancel out. K is constant. And Charles law क्या हमें बताता है? If pressure is kept constant. ये बताता है हमें चार्ल्स लॉ?
जी
Sir, Na क्या है?
Avogadro's number.
Okay.
6.02 × 10⁻23. So from here, we'll get T equals to 2 by 3 K into kinetic energy. These all factors are constant. So hence T is proportional to kinetic energy. और अगर हम चार्ल्स लॉ पे जाएं यहां से ही, so again we'll take help from PV equals to 2 by 3 N into kinetic energy. And pressure is kept constant, so volume would be equals to 2 by 3 N over P into kinetic energy. This whole factor is constant. So V is equals to constant into kinetic energy, and V is proportional to kinetic energy. But we already have discussed that if kinetic T is proportional to kinetic energy, that means V is also proportional to temperature, and this is Joul's law. Cause यहाँ से अगर हम remove करें, so V equals to constant into temperature and V over T equals to constant, यहाँ से आ जाएगा. तो ये तीनों गैस लॉज आगे. बाकी इंटरनल एनर्जी का कॉन्सेप्ट होता है. इंटरनल एनर्जी हम लोगों ने डिस्कस की हुई है. इट इज द सम ऑफ ऑल फॉर्म्स ऑफ एनर्जी दैट अ सिस्टम पोजेस. गैस, बिकॉज इट्स ऑल अबाउट गैसियस सिस्टम्स, गैस सिस्टम्स में बात हो रही है. सो गैस के पास काइनेटिक एनर्जी तो ऑब्वियसली होती है बिकॉज ऑफ द रैंडम मोशन ऑफ द पार्टिकल्स. हाउ डू वी जस्टिफाई द पोटेंशियल एनर्जी गेन्ड बाय देयर बाय द सिस्टम? हाउ डू वी जस्टिफाई दैट? अली, अरहम.
क्वेश्चन रिपीट कर लें.
Kinetic energy is very
Question.
simple. Kinetic energy possessed by a gaseous system is very simple to explain. Na? How do we justify the potential energy gained by the system? Or by the system? Yeah. Ali,
पोजीशन की बात या इलास्टिक पोटेंशियल एनर्जी?
last potential energy.
When they hit each other?
Obviously, when discuss about the gas, they are at a certain position in a cylinder. So due to their position in the system, they have potential energy, and due to their motion, they have kinetic energy. Also keep this in mind that there is this term used as state functions, and pressure, volume, temperature, and internal energy. They all are the state functions. And by state functions, we mean that only their initial and final condition is important. It doesn't matter through which way we have achieved that difference of value into it. Okay. This next part is work and heat, and this would be the last work and heat and first law of thermodynamics. So when it comes to work and heat, we have the formula of work as F into D. And from the pressure, we know that force is equals to pressure into area. Putting that into the equation, pressure into area into change of distance, जो उसने travel किया across the pressure. Area into D would give us the unit of volume. So W is equals to pressure into delta V. अब यहाँ पे हमें एक चीज जो इंपॉर्टेंट है, जो अक्सर क्वेश्चंस में आती भी है, एंड दैट इज सिस्टम. दिस इज आवर सिस्टम. Heat in and work out is considered as positive, and work in and heat out is considered as negative. So from here we get the first law of thermodynamics. And the first law of thermodynamics tells us that when a heat is given to a system, it appears as the increase in internal energy of the system plus some work is done by the system. Okay. When it comes to this first law of thermodynamics links with two processes, very important processes, which is isothermal process and adiabatic process. Isothermal process को कैसे define किया जाता है? When the
Energy remains constant.
temperature, when the process is carried out at constant temperature. at constant temperature. So if the temperature is constant, that means internal energy of the system is constant. So U would also be constant because we know that temperature and energies are directly proportional to each other. So from there, Q would be equals to V. And the adiabatic process is a process in which no heat enter or leave the system. इसके अंदर फिर if then Q would be equals to 0 and W would become equals to minus delta U or U would become equals to minus W. This is the adiabatic process. Adiabatic process के अंदर हमारे पास एग्जांपल्स आ जाएंगी क्लाउड फॉर्मेशन की और इनके जो ग्राफ्स होते हैं उनको एडियाबैट्स कहते हैं और आइसोथर्मल के ग्राफ्स को आइसोथर्म्स कहते हैं इनके ग्राफ बनते हैं प्रेशर वर्सेस वॉल्यूम के अगेंस्ट कर्व आएंगे हमारे पास सॉरी कर्व मैंने कुछ ज्यादा ही दे दिया थोड़े फ्लैट कर्व्स आते हैं प्रेशर एंड वॉल्यूम ये एडियाबैट का होता है एंड आइसोथर्मल का ग्राफ आएगा हमारे पास वो उससे थोड़ा ऊपर होता है आई couldn't draw it properly but ये आइसोथर्म होता है और ये जो लेस स्टीप है वो एडियाबैट का होता है क्लाउड की फॉर्मेशन हो गई एक्सपेंशन एंड कंप्रेशन ऑफ एयर थ्रू विच साउंड की जो ट्रैवलिंग होती है वो भी एडियाबैटिक प्रोसेस के अकॉर्डिंगली होती है एंड इफ वी डिस्कस अबाउट द क्या कहते हैं sudden escape of air from a tire that also comes under the adiabats. So let's get back to the syllabus part. We have discussed the Boltzmann constant. Yes, that's done. Recall PV equals to NKT. Yes, we have discussed that and we have discussed that as well. Basic assumptions of kinetic theory of gases. I'll get back to this again. We have discussed this formula. Average, इसको क्या कहते हैं हम लोग? What do we call this?
कौन सी चीज
Average speed.
नोट मीन्स में
हाँ मतलब ये एवरेज स्पीड जिसके अराउंड ये ऐसे वो लगी हुई होती हैं
Kinetic energy?
brackets that tells that it's average and c is given as speed so average speed of the object when it comes to kinetic particle theory what assumptions do we make there are only a few of the assumptions and we'll get back to this part we have discussed this part. We have derived this equation 3 by 2. Only this part is left. We'll discuss it later. Let's discuss the basic assumptions of kinetic particle gas theory. What is the first assumption? First assumption is kinetic theory of gases. First is finite volume of gas contains or consists of consist of large number of molecules. Second point is the size of molecule is much smaller than the separation between the particles, between the molecules, separation between the molecules. Third point क्या है? They are in random motion, always in random motion, and they collide with each other. And upon every collision, they change their direction. And इनकी collisions जो हैं वो elastic होती हैं in isolated system, elastic collisions. And one of the most important part is molecules do not apply force on each other unless they come in contact with each other. So that are the major points of kinetic theory of